Alright, so we're going to do a video on parallelogram rules now. I know you have these rules in many different spots. This is one of those things you really have to have memorized, and that's just really no other way around it. What you can do on the test, if you forget some of these rules, is to sketch a parallelogram, and that might give you a little bit of a, jog your memory about what the qualities, the properties of a parallelogram are. So I'm going to mark it in, and then I'll pause it, and I'm not going to, you don't have to watch me write all these. But what we know is that, first of all, the two opposite sides are congruent. We also know the two opposite sides are parallel. And what we always talk about with parallel lines, either to prove lines are parallel or if you're given that lines are parallel, is to look for congruent angles. So that's what we know about a parallelogram. Those are kind of the main things. Additional information is that the opposite angles are congruent. And here's the big one, kind of the easy one to forget. I guess before I say that, the other thing we know, since these opposite angles are congruent, the consecutive angles, so these two angles here, these two angles here, any angles that are next to each other, those consecutive angles always add to 180. So that's another helpful piece of information. The other thing that tends to get confused is that the diagonals bisect each other. So what we talked about was that since this is kind of a slanted shape, it's kind of pushed over on its side, the diagonals are not congruent, but they do cut each other in half. So those two pieces are congruent to each other, and these two pieces are congruent to each other. So I'm going to pause if you want to find it in your own notes, or if you just want to unpause and copy it down. I will put up the 5 properties of a parallelogram right now. All right, so there you go. You can unpause or pause if you need to. I'm going to move on. When we start doing proofs with these parallelograms, you do have one on your homework, I believe, tonight. These are also going to be used as the proof rules for parallelograms. So it all goes together, whether it's an algebraic question or a proof question. That's what you need to know. All right, rectangle. If it helps, draw the picture. So the first thing we know about a rectangle is that all the angles are 90s. That should be an automatic one. The next thing we know, since this shape is perfectly kind of squared off, it's not slanted over or tilted like the parallelogram is. The biggest difference here is that the diagonals are congruent. So we know those two cut each other in half, and these two cut each other in half, but they're also congruent, so all 4 of those pieces are congruent. And so what we kind of learned a lot from this unit is that it sets us up with some isosceles triangles, which is also very helpful. So I'm going to pause again. You can write these rules on your own. I'll fill them in so you can copy them down, and then we'll move on to rhombus. All right, so there is our rectangle rules. Pause if you need to. All right, a rhombus has 3 more special things about it. Now remember, a rhombus has 4 equal sides, but it's still that kind of slanted figure. So 4 equal sides, but that doesn't make it a square. And the reason it's not a square is because, like I said, it's slanted, it's tilted a little bit. Those aren't 90s in their angles. But what is special about a rhombus, besides the fact that all those sides are congruent, has to do with the diagonals. All right, so 2 special things about the diagonals of a rhombus. First of all, the diagonals bisect the angles. So they cut each of those opposite angles into 2 equal parts. All right, notice the diagonals are not congruent. They're not congruent. But they do bisect the angles. And the other special thing is that the diagonals are perpendicular. So all of these angles here in the middle are all 90s. So there's our special rules about a rhombus. So I'll pause now. You can write those down. Okay, so there's our rhombus rules. And now, last but not least, when we draw the square has everything. Opposite sides are congruent. All four sides are congruent. All four angles are 90s. The diagonals are perpendicular. The diagonals are congruent. The diagonals bisect the angles. So that actually also tells us that all these angles are 45s, which is also a really helpful piece of information. So we have isosceles right triangles because they're 45 degrees. The sides are congruent. This angle is 90, so the square tells us a lot of stuff. So the square has all rules. Okay, so pause if you need to. Get those rules written down, flashcards, whatever you can do to help memorize these. These are really important for our proofs. So flipping to the next page. Now to prove a quadrilateral as a parallelogram. In our proof unit, we did a lot of proving a shape as a parallelogram. So kind of the two straightforward ways, the two main ways, would be to show that two pairs of opposite sides are congruent and two pairs of opposite sides are parallel. And remember, we proved lines were parallel by looking for congruent angles. So alternate interior, corresponding, those things. The third rule is kind of that bonus rule. So if I draw a parallelogram real quick, the third way to kind of show that a quadrilateral is a parallelogram is to show that one set of sides are congruent and parallel. So that's kind of a helpful rule. So one pair of sides. One pair of sides are congruent and parallel. So it's kind of a nice bonus rule. All right, so when we start looking at our proofs, that's another really important thing to keep in mind. All right. Now, I forgot to write something in the questionnaire. Using the diagrams, we'll prove each statement given that A, B, C, D is a parallelogram. So we have to first know that these shapes are parallelograms. Okay, so I'm going to kind of do these like paragraph proofs. So if you want to do your statement of reason thing, that's totally fine. I'm just going to save space and just kind of talk about what I'm doing. So we're trying to prove that angle ABD, so that guy right there, is congruent to angle CDB. So congruent to that angle right there. Now, first thing, what some of you might think is that, well, it's a parallelogram, so the opposite angles are congruent. Remember, that only works if it's the entire opposite angle. These are just pieces. So that's, that's not the right first step. Now, we had a question like this back, early in the year, and what some of you did was, which was completely fine and completely correct, was you looked at these triangles here and here, and you did, vertical angles, and maybe you said that the diagonals bisect each other, maybe you said the opposite sides of a parallelogram are congruent, and then you said the triangles are congruent because of SAS, therefore the angles are congruent because of CPCTC. But watch all we really need to do here. We know this is a parallelogram, so we know that these sides are parallel. Right? And if those sides are parallel, and there's my transversal, it means automatically, without a doubt, that my alternate interior angles are congruent. So remember, when we're looking to prove angles, look for the parallel lines first. So the first thing I can say is that AB is parallel to CD, Because a parallelogram has opposite sides that are parallel. And now a big thing. Now that we know those lines are parallel, we can say for a fact that the alternate interior angles are congruent. So we can finish this thing off by saying angle ABD congruent to angle CDB because lines are parallel if and only if alternate interior angles are congruent. So yeah, this is definitely not a full-blown proof, but it's just using our rules. You know, this might be part of a proof that we look at later. So we'll definitely spend some time doing these kind of more challenging rectangle and rhombus and parallelogram proofs that you'll see in the regions that are 4 or 6 pointers, but they're all built on these rules here. All right, and the next thing we want to prove is that AY is congruent to CY. So yeah, same thing. You could, you know, use all your parallelogram rules and do our triangle congruency with SAS or ASA, or you know, use the CPCTC. But to prove that those two pieces are congruent, we just need to use our parallelogram rules again. So we know in a parallelogram, the diagonals cut each other in half. So those diagonals bisect each other, and that's where we can start. We can say AC and BD bisect each other because in a parallelogram, diagonals bisect each other. All right, so again, this is not a full-blown, you know, 8-step, 10-step proof, but these are parts of big proofs that we're definitely going to look at. You know, we'll use our rhombus rules, we'll use our rectangle rules, we'll use our square rules, but this is just a foundation, a building block of what one of those big proofs might look like. Now, since we know that the diagonals bisect each other, it means these two pieces are congruent. That's not what we're looking for. It might be in another proof. But more importantly, it means that AY is congruent to CY because, and we can say this any way we want, I guess I'll just say because when lines bisect each other, it cuts them into two congruent pieces. All right, guys, continue watching videos. If you're done with this one, if you got this one down, you can look at some of the other ones I have posted, but just really begin memorizing these rules. It's a very important thing for the proofs. And, you know, I'll see you in class. Good job.